Evaluate the following definite integrals. In part A, we got a function 2 over 1 plus t squared from 0 to 1. So this is a fraction. Unfortunately, there is no quotient rule. And bottom, we cannot separate into two fractions because we got 1 plus t squared. So this is as a block. But we know that when we have, let's say, 1 plus x is squared and just 1 on the top, this fraction is familiar to us. How? Derivative of tangent inverse, arctangent, derivative of tangent inverse x is 1 over 1 plus x squared. So in our case, antiderivative of 1 over 1 plus x squared is just tangent inverse. So this is a fraction but special fraction, so we can find its antiderivative easily. So this is this constant 2, we can always think 2 times 1, 2 can be pulled outside. So 0 to 1 of 1 over 1 plus t squared. 2 is outside. Now let's find antiderivative of this fraction, this function, and that is in fact tangent inverse. Tangent inverse, the variable is here t, tangent inverse t, and we got limits 0 to 1, that's here. Or we could have left 2 inside and just do this, which is the same thing. Now 2 times, now upper limit, tangent inverse of 1 minus tangent inverse of 0. Now we need to find the values of tangent inverse of 1 and tangent inverse 0. So remember, tangent of pi over 4, tangent 45 degrees is 1, and tangent of 0 degrees or 0 radians is 0. That means tangent inverse of 1 is pi over 4. And here tangent inverse of 0 is 0. So using those values, we got here 2, this is pi over 4 minus 0. Minus 0 does not count. 2 times pi over 4, 2 goes 4 2 times, so pi over 2. Final. Okay. Next question here, square root of 2x. Okay, this one, we know that square root of 2x is square root of 2 times square root of x. Okay, we can do this. How does this help? Then we can get rid of this square root, because this is just a number, we can just pull outside. When we have a constant and a function, we can ignore the constant, just go for the function. So this is 0 to 9. As I just said, this is root 2 root x. Now I can pull root 2 outside, and that leaves root x. And root x is what? X raised to 1/2, by the way. I'm going to write root x in this form. It's like x raised to n, and we know that the power rule when we have xn is antiderivative is xn plus 1 over n plus 1, as long as the bottom is not 0. So that's the case here. Root 2, I'm going to integrate. X raised to 1/2 is x 1/2 plus 1 from the power rule. What is that? 1/2 plus 1, that's 3/2 divided by the same thing, 3/2, and we have to go from 0 to 9. That's in fact x. X equals 0 through x equals 9. Now we plug in upper limit and lower limit for x. In fact, 3/2, when we bring, we can pull all the way outside. This 3/2 bring to the front is 2/3, and it has nothing to do with the limits, because these are for x. Okay, we don't write these x equals, but that's the case. Whatever the variable, it could be t or v. So 3/2 can be pulled outside. So root 2 already outside. 3/2 is just clips 2/3, because this is on the bottom. Now upper limit 9, replace x by 9. 9 raised to 3/2 minus lower limit 0 raised to 3 halves, or 0 raised to any number is just 0. Now this is in fact 2 root 2, there is no cancellation of anything, minus 0 does not count, I mean just nothing, times what is 9 raised to 3 halves. Now you can use your calculator. 9 raised to 3, yeah, we must use parentheses, enter. By hand you can do the following. So 9 raised to 3 halves is in fact 9 is 3 square, and this exponent and old exponent in multiplication, 2 cancel, 3 cubed, 3 times 3 times 3, 27. So this is 27, or you can use your calculator. We can, 3 goes 27 9 times, 3 goes 3 once, and 1 does not count. So 9 times 2 root 2, 9 can only multiply this one, okay? 9 times 2, 18 root 2, not inside. So that's the final answer, okay? Final.